So today we're going to be learning about Newton's laws of motion. Now if you're wondering who is Newton, it's this guy over here. He's got this portrait of him. So anyway, Newton was one of the most famous scientists we know to this date. So he actually, in his Principia Mathematica in 1687, he created these three laws of motion, which is Newton's laws of motion. Now there are three of them. So we're going to be, right now, in this video, we'll be specifically looking at Newton's first law, which is Law 1. An object at rest will stay at rest, and an object in motion will stay in motion, unless acted upon by an unbalanced force. So if you guys don't understand it, don't worry, I'll explain a little more. So it's saying that an object at rest will stay at rest. Now let me give this ball, a ball here. And then we'll get this line. That here. So this is the ball, and it's right now staying at rest. So it's kind of a bit suspended in air, but it's supposed to be actually there. But anyway, it's supposed to be in the ground. So anyway, so the object at rest is right now at rest. So the object is a ball, and it's still on the floor. So it makes sense if you put maybe something like the computer here. If you put a computer on a desk, it'll always stay there unless you move it or give some unbalanced force that causes it to move. So that's pretty much that. Now let's see. So the object in motion will stay in motion. So let me go ahead and make another one and try to emphasize it moving. And now I'm going to draw some things that signify it's actually moving. So the ball is moving, but eventually it will stop. And we have to apply force to that. So the object in motion will stay in motion kind of sounds a bit loosey-goosey here. But actually, the main thing is that there's actually an unbalanced force when the ball is rolling. Now there are actually two of them. One is friction with the ground, and one is also something called air resistance. So pretty much friction will kind of slow down the ball, and air resistance makes it even slows it down even more. And eventually, after some time, it'll stop. Now, if you're now in an object in motion and stay in motion, if you guys know that those spinning tops that sometimes you play with, so those spinning tops, when we're anywhere, it falls down after some time. But if you put it in a vacuum, it will, because since there's no air resistance anymore, that it'll just keep spinning. And friction, same thing. If you get a ground that's very frictionless, then it will also spin forever. But it also needs air but it also needs no air resistance. So in a vacuum, will actually suck up all the air. So that's pretty much what Newton's first law says. Now I'm going to also give another example if you think that the spinning top and the ball example is kind of getting you a little confusing. Now there's also another thing, that also an object in rest that will stay at rest. So tires tend to stay at rest, and that's something called inertia. Now, what is inertia? Let me go and explain it to you. So inertia is the resistance. Of any physical object to any state of its change. See if I'm making any typos. No. So that's pretty much what inertia is. Now let me give you a bike example. You know how you feel that when you're starting to pedal your bike, it's pretty hard doing that? Here's why. Because the object, the bicycle, wants to actually stay at rest. So it just wants to remain there still. But you want it to move. So you have to overcome this inertia to actually pedal your bike. So that's pretty much what they're saying. So it means that you have to put more power in that so it can move. And once you overcome it, it's as easy as pie, because now the object, the bicycle, wants to stay in motion. Now I hope you understand Newton's first law And if you do, we can go move on to the next video. Now, thank you for watching, and don't forget to check out our next video on Newton's second law, and I'll see you next time.